Linux or Unix attacks. On Linux or Unix system, vast majority of log files are written in standard ASCII text. It is not specialized binary format like logs of Windows machines. To edit Linux and Unix logs, attacker requires root privileges or privileges of a specific application that generates the log, such as web server daemon. How do attackers cover tracks? Attackers employ automated scripts that pass through the system logs, automatically deleting to cover their tracks. In hands of an experienced attacker, the automated log editing scripts can quickly and efficiently hide evidence of an attack. Script kiddies often attempts or delete files that do not exist on a particular flavor. It would also create series of additional log entries documenting these errors. Sophisticated attackers don't need such scripts. They begin looking at the syslog configuration file, normally found at etc syslog.config, to determine where the log files are located. The configuration tells syslog-d where in the file system to put the logs. Once log location is discovered, attacker with root privileges directly edit the logs. Root privileges could be obtained by a buffer overflow attack, and logs are plain ASCII text. With root privileges, the attacker edit the logs directly. So attacker can alter the log files using their favorite editors such as VI, Emacs, gedit, Pico or other text editing tools. Sophisticated attackers systematically go through log files and remove entries associated with their gaining access to the system, like failed login attempts or specific application error messages. As because files are text rather than binary format, they can be altered and saved without any indication of file corruption. Altering accounting files in Linux and Unix. Main accounting files in Linux and Unix are UTMP, WTMP and last log files. UTMP, WTMP and last log files are written with a special binary format. UTMP and WTMP files are stored as so-called UTMP structures. Last log is stored in a variety of different Linux and Unix machines. When an attacker attempts to edit these files using standard text editor, files will appear corrupted and cannot be properly read by the system. It appears gibberish as it is written in a binary format. To edit these accounting files, attackers use a tool accounting files. Attacker use a tool that can read and rewrite the special binary format. At packetstormsecurity.org Unix penetration log wipers, attackers can choose from several tools with complete inventory available. Particular tools are fine-tuned for specific varieties of Linux and Unix. The remove tool allow for removing entries from UTMP, WTMP and last log for several Unix systems. The remove program also allow an attacker to change last login time, location, status of any users to that what the attacker desires by editing the Unix last log file. Other tools include WTMPED, Mari, Cloak, Log, WEdit, WSAP, and zapper. Altering Linux and Unix shell histories. Additional type of accounting and logging of particular concern to attacker is individual users' shell history files. Shell history files stores a list of all commands recently entered by the user into the command line. Whenever user type in Linux or Unix command, the shell stores the command typed, maintaining a history of interaction with the system. Shell history contains around 500 or so commands, although this is configurable. Command shell uses this history to allow the user easy access to previously entered commands. It makes repetition commands easier to enter. If attacker takes over a user's account or creates a brand new account to attack from, the shell history file contains a list of all commands entered by the attacker. The shell history files are stored in individual users' directories and have names such as .bash_history. Each shell history from a user messaging around is present in etc/shadow file, where encrypted user passwords are stored. Next, there is the ls command, vi command. These commands are typed into the command line by attacker and stored in shell history file by command shell program. Attacker first types ls command to get listing of contents of the current directory, and when attacker use text editor vi, it is to view and possibly alter the etc shadow file. Attacker must have changed a password or simply looked through the file for other account names and password hashes. After getting a copy of the shadow file, attacker might start cracking password representations. Like standard Unix log files, shell histories are written in plain ASCII. It can easily be edited using attacker's favorite text editing tool. The attackers configure the length of the shell history file to simply 0 so that no history will be maintained for account used for attacks. 0 length of shell history files raise suspicion of system administrators. So, attackers opt to remove commands that raise suspicion rather than completely deleting the history. Attackers also add lines to another user's shell history file, possibly framing that user or diverting suspicion. It's important to remember that shell history is written when the shell is exited. User won't see the most recent commands in shell history. They are stored in memory until the shell is exited gracefully. At that time, they are written to shell history file. This brings up significant impact for attackers editing shell history. Attackers' command used to invoke the editor will be placed in shell history file. An investigator sees something like vi.bash_history, and so the investigator comes to know an attacker has altered shell history. To overcome this problem, attacker exits the shell, logs back in, creating another shell, and then try to edit the shell history file again to remove line about editing the shell history. It's a chicken and egg problem for attacker. Two widely used solutions to this dilemma for the attacker are: First, the attacker simply set history file to size 0. A more comprehensive way of dealing the issue is simply kill the shell instead of exiting it. By killing running shell process, attacker deprives ability to write its history. Thus, instead of logging out, attacker can kill the shell by simply running a command like kill -9 PID underscore of the shell process.